Okay, let's give you guys a calculus 1 optimization problem. So here I've got a string of length 10. I'm going to cut up into x number of pieces. So let's just say x equals 5. So I'm going to get the whole length, cut up into 5 equal pieces. 1, 2, 5 equal pieces. So this length here must be 2. This length must be 2, 2, 2, 2. So y is going to be defined as the product of all of them. So it would be 2 times 2 times 2 times 2 times 2. So that would be 2 to the power of 5. So y is really defined as this. You get the whole length, which is 10, and then you cut up into x equal pieces, and then you power it by x. So y is given by this. So your job is to find a value of x that will give you the biggest value of y. So press pause and have a go. Okay, so to do this, if you get a graph plotter and plot this graph, it will look something like this. And your job is to maximize y. Well, you maximizing y is you finding out when the gradient will be 0. So the first step is to differentiate this. So notice that when you look at this, it's like one bubble to the power of another bubble, and this bubble here contains x, this bubble here contains x. So it's like me asking you to differentiate this, which we've done before. So to differentiate this, we need to take the natural log of both sides. So that will then take us to here. Take the natural log of both sides. Where that we are here. Take the natural log of both sides. So take the natural log of this. Take the natural log of this. When you take the natural log of something to the power of another thing, the exponent is able to come down here. That will then give you this, and then this will stay the same. This will stay the same. And remember, you take the natural log of the left-hand side. That will then give you this. So from here, take the natural log of both sides. That will then give us this. And then now use implicit differentiation. Differentiate natural log of y, that would be 1 over y. But because y is a function of x, you need to stick dy by dx in here. And looking at this, you've got one block multiplying another block. This block contains x. This block contains x. So you know you've got to use the product rule. So the product rule is you differentiating the first, leaving the second alone. So when you differentiate x, it would be 1, and then you leave this alone, and then leave the first alone, and then differentiate the second. When you differentiate this, it would be 1 over the bubble, 1 over the bubble, but then you've got to times the derivative of the bubble itself. So when you times the derivative of the bubble itself, looking at this, it's really 10 times 1 over x. So it's like one block. So just looking at this bubble here, this is like 10x to the power minus 1. So when you differentiate this, the negative comes, so it will give you negative 10x, and then the power gets minus by 1. So it will give you this. And then when you tidy this up, it will be 1 over x squared times negative 10. This gets multiplied to the top. It will give you this thing here. So that's this thing here. Okay, so let me start again here. When you differentiate this, it will give you this. Now use the product rule on this. So you've got two blocks. The product rule is differentiate the first, leave the second alone. That will then give you this. And then now leave the first alone, differentiate the rest. The rest turns out to be this. So you leave the first, you leave the first alone. That will then give you this. And now differentiate this. It will be 1 over the bubble. 1 over the bubble, and then you've got to times the derivative of the bubble itself, which will then give you this thing here. So it will give you this ugly thing here. So this ugly thing is really one block multiplying another block multiplying another block. This block here gets multiplied to the top. This block here gets multiplied to the top. So it's really 10 times x times negative 10. So think about it. It will then give you this thing here. Okay, so how from here you've got 3 blocks. This thing here gets multiplied to the top. This thing here gets multiplied to the top. That will then give you this. And then this denominator stays the same. So now it's just a matter of us tidying this thing up. So hang on. So when you look at this, the x cancels out. That will then give you this thing here. By the way, I'm dragging the negative out. That will then give you this. And then you've got divided by, well, divided by this thing here is the same as multiplying the reciprocal of this. So that would be x over 10. So now top times top, bottom times bottom, well, this whole thing here equals 1. Okay, so that will then take us to here. Remember, our graph looked something like this from earlier. We are trying to find the highest point. Well, at the highest point, dy by dx equals 0. So we can put 0 into this block here. So, well, 0 times this thing would be 0, and then that will then take us to here. So remember, we are just trying to find the value of x. We are trying to make x a subject here. So now add 1 to both sides. That will then give us this thing here, and then here exponentiate both sides with base e. So that will then give us this thing here. Well, we've seen this before. Whenever you have e to the power of the natural log, these two, in a way, they cancel each other out, leaving you with just a bubble. So that will then take us to here. So remember, you want to get x on its own, times both sides by x, divide both sides by e. That will then give us this thing here. So our answer would be this. You should cut this string up into e number of pieces, and the value of y, the maximum value of y, will be given by this. So x equals e, basically. Okay.